Section 1.6, a library of parent functions. Believing that you can is half the battle, unknown. Below are graphs of 7 functions, and we know them as the parent functions. Just like our parents, we have, as their kids, we have similarities to them. So for example, my eyes might be like my mom's, my hair might be like my dad's. So in math, these parent functions, any functions that look like them will have similar characteristics. The first one is the constant function. And the constant function is basically a horizontal line crossing through the y-axis. In this example, it crosses at c. So this is the value c here. So the domain for this, as you can see, we're using all the x values. So this would be from negative infinity to positive infinity. And the range, the only y value being used is c. So c would be my range. And then this function, we need to determine if it's even or odd. If you notice, the graph has symmetry on the y-axis. Basically, if I fold this on the y-axis this way, this will fall on top of it. Since it has symmetry on the y-axis, then we say that it's even. And then this function is constant, and the interval that it's constant on is from negative infinity to positive infinity. So from here to here, this graph is constant. The next function is the identity function, also known as the linear function. And the equation for that is f of x equals x. And so you can see this is a line, and we looked at lines in section 1.3. And so the domain for a line is always going to be negative infinity to positive infinity, as we can see from the x values being used, or all the negative and positive values. And then the range is the y values, so we're going from negative infinity to positive infinity. This function has symmetry on the origin. As you can see here, if I fold on the y-axis and then on the x-axis, this will land on top of this. So we say that this is an odd function. And also we can see the exponent for x is 1, making it an odd function. This graph is increasing, and it's increasing from negative infinity to positive infinity. The next one's called the absolute value function, and when you graph it, it's going to be a V-shaped graph. So V-shape. The domain goes from negative infinity to positive infinity. We're using all these x values. The range goes from 0 to infinity, from here to infinity. This graph is going to be even since it has y-axis symmetry. If I fold on the y-axis, this line will fall on top of this line. So if I fold it this way. This has both increasing and decreasing. So it's decreasing from here, negative infinity to 0. So on this interval, negative infinity to 0, the graph is decreasing. And then from 0 right here to infinity, the graph is increasing. The next one is the quadratic functions. And these are going to be quadratic if the highest exponent of x is a 2. And this is a U-shaped graph. And so the domain goes from negative infinity to positive infinity. The range goes from 0 to infinity. And then this also has symmetry on the x-axis. So we say that the graph is even, since it has symmetry on the y-axis. If I fold it, this will land on top of this. And it has both increasing and decreasing. It's decreasing from negative infinity to 0. And then it's increasing from 0 to infinity. The next one's called the cubic function, and it's going to be cubic if the highest exponent is a 3. The domain goes from negative infinity to positive infinity, since I'm using all the x values here. And the range goes from negative infinity to positive infinity. This has symmetry on the origin, so we say that the function is odd. If you fold on the y-axis, this will land on here, and then on the x-axis, it will land on here. This is increasing from negative infinity, so from negative infinity here, all the way to positive infinity. This part here looks like it might be constant, but if we zoom in, the graph is actually keeps increasing. The square root function is a function with the square root here, and it starts at 0 and shoots up to infinity. So the domain was going to go from 0 to infinity, and the range is going to go from 0 to infinity. This is going to be neither. There's no symmetry. If I fold on x, there's nothing here. On the y-axis, there's nothing here. If I look at the origin, there's nothing for it to land on. This is increasing from 0 to infinity. The next one is the cubic root function. So notice it's has a cube root. And so the domain is still negative infinity to positive infinity. The range is still negative infinity to positive infinity. This is going to have symmetry on the origin. So we say it's odd. And this graph is increasing at every part of the x-axis from negative infinity to positive infinity. Go ahead and try the next one. I'll give you a second to look at that. So the next one's called the reciprocal function. So the domain here goes from negative infinity all the way to 0, union 0 to infinity. Then the range is going to go from negative infinity to 0 again. So we go all the way up to 0, but it's never going to touch. And then it starts at 0 to infinity. This function is odd since you have symmetry on the origin. If I fold it this way, it lands here, and then I fold it down and it lands here. Then we have that the graph here is decreasing from negative infinity to 0. And then the graph is also decreasing from from 0 to infinity. Then we have the next function, which is a square root function. So the domain is from negative infinity to 0, union 0 to infinity. So all these x values here. The range goes from 0 to infinity. This is going to be even since there's symmetry on the y-axis. And the graph is increasing from negative infinity. So from negative infinity. And then the graph is increasing to 0. And then the graph starts to decrease from 0 to infinity. This is negative infinity. Okay, so those are your basic functions. The ones that we're going to use the most are the following. Then put a star next to them. So the ones that are used the most is the linear function, the absolute value, the quadratic function, the cubic function, and the square root function. And so those are the ones that we'll use the most, the reciprocal.